Okay, dear students, welcome to the class. This is the HVAC class. I am going to talk about the different topics today. The first one is three-way valve and proportional thermostat. I am writing it down. Three-way valve and proportional thermostat. It covers unit 3 and 4 both. It is there in both the chapters. Let me draw the diagram first. I am talking about three-way valve and proportional thermostat. Camera was little mismatch. Now I have fixed the camera again, focusing on the whiteboard. This is air handling unit, HU. This is HU, is defined as air handling unit. Now what happens in this case? The air handling unit is there. In the air handling unit there is a butterfly valve. This is butterfly valve. This is Hvac strainer. This is connection of the three-way valve here at the return supply line, and then there is a pressure gauge, there is a temperature gauge. At the outlet there is a temperature gauge, there is a pressure gauge, and after that there is the three-way valve. Three-way valve is connected with the proportional thermostat. This is the wiring connection to the thermostat, and this is the return connection from the three-way valve to the supply chilled water. And then it comes to balancing valve. This is balancing valve, this is butterfly valve. I am defining the whole system in totality. Try to understand the system. In this system, we have a air handling unit in which the chilled water is coming from the chilling machine. Try to understand the cycle first. I drew in the last classes the chilled water diagram and condenser water diagram. At this point of time, I am talking about chilled water piping diagram. The chilled water piping diagram comes from chilling machine to the air handling unit. Chilled water piping comes from chilling machine to the air handling unit. From the air handling unit, it comes inside the air handling unit and then goes outside the air handling unit. In the air handling unit, it has a butterfly valve, it has a Hvac strainer, it has a pressure gauge, it has a temperature gauge, a three-way valve, a balancing valve, and a butterfly valve. Now the function of the butterfly valve generally isolates the system. Means you move this knob, the butterfly valve disconnects the system from the rest of the piping. That's an isolating valve. That means when you are using butterfly valve, the system gets totally isolated from the chilling machine. So when we have to clean up the HU, clean up the cooling coil here, clean up the blower here, in that case we need to have this system. Let me draw the total system of HU, whatever is there in general. We have a chilled water piping here. This is chilled water piping. We have a blower here. This is the HU. This is the HU. We have a blower here. We have a chilled water piping here. This is pre-filter. The diagram of HU I have drawn earlier also, so you know about the diagram. Again I am repeating it. This is pre-filter. This is chilled water pipe. This is blower. Blower means fan. This butterfly valve are closed and I disconnect the system from the chilling machine. As soon as I disconnect the system from the chilling machine, the pipe water connection is cut off. The moment the water connection is cut off, I can take out the chilled HU, air handling unit. I can enter into it and clean the chilled water pipe. We can clean the pre-filter and we can check the blower connection with the electricity problem or anything. That means for the maintenance of the HU, we are to disconnect by closing this butterfly valves. Now after the HU is put in place, then we again close the knob, let the portion be, open the knob, let me open the knob and let the portion be connected again to the chilled water piping. Chilled water comes through this. Chilled water, remember, it comes at a temperature of 44 degree Fahrenheit and goes out at a temperature of 54 degree Fahrenheit. I told it during the last chilled water piping diagram that chilling machine takes water at 54 degree Fahrenheit. This is going to chilling machine at 54 degree Fahrenheit and it cools it down to 44 degree Fahrenheit, and at 44 degree Fahrenheit the chilled water is supplied to the HU again. That means there is a delta T of 10 degree Fahrenheit. This 10 degree Fahrenheit determines the heat the cooling happening in the cooling coil. That is, since chilled water comes here and air is passed through this blower sucks air, you know that, sucks air from this prefilter. Now, as it passes through the chilled water pipe, it gets cooled. It gets cooled due to the temperature. At a temperature it comes at 44 degree Fahrenheit, and this chilled water transmits or rejects the coolness to the air. Rejecting the coolness, giving coolness to air means what? It picks up heat. The chilled water picks up heat. So at 44 degree Fahrenheit it gets heated at 54 degree Fahrenheit. And at 54 degree Fahrenheit it comes out and goes out to the chilling system. Now here is the balancing valve. You can see this is balancing valve. I have shown here balancing valve. This balancing valve is used to regulate the piping. What means regulating? That means we are regulating the chilled water passing out through the HU. We can increase or decrease the flow depending on that. Why should we increase or decrease the flow? Depending on the requirement of the temperature in the room. More the flow, the more is the heat transfer. Less the flow, less is the heat transfer. So I can, when I feel the temperature difference can be maintained to a lesser amount, then we can close or open the knob accordingly, depending on the situation. Now there is another thing what we call as three-way. This is three-way valve. Three-way valve has a three-way. One is inlet, one is outlet, and another is another outlet. That means I take a bigger diagram of this. This is three-way valve, the same three-way valve here. This is the inlet, this is the outlet, and this is the outlet again coming to the supply chain. There is the supply chilled water pipe. So this is connected to proportional thermostat. I have written this is to thermostat. That thermostat is proportional thermostat. It is not a simple thermostat. Simple thermostat generally measures a particular temperature and does not give signal to anybody. It just measures. In case of proportional thermostat, it measures the temperature and gives signal to the three-way mixing valve. Now depending on that signal, the three-way mixing valve opens or closes. It depends on, depending on that, see very minutely. The water after getting hot comes here. Now this is controlling the flow of water. Now depending on the temperature requirement in the room, it generally controls the water circulation. That means if the room requires more water, that means the chilling required in the room is more. In that case, this valve, this port opens and more water flows through that. And this port closes. The moment this port opens, this port closes. So less water flows through that and more water flows through that, and it occurs proportionally. That means slowly. It doesn't suddenly stop water here. It doesn't suddenly open water here. It controls regulates the water flow. Gradually it closes water flow here. Gradually it opens the water flow here. That is why it is called proportional thermostat. That means depending on the proportionate temperature, the three-way valve operates. So when the chilled water requirement is more, that is the cooling required is more, then this port opens, more chilled water flows. And this port closes, and less chilled water flows to the supply line. But when it is found that the chilling is more in the room is getting overcooled, and we don't require much chilled water there, in that case what we do, we close this port gets gradually closed, this port gets gradually open. Now what is the gradually? Gradually means slowly it opens, slowly it closes, depending on the direction from the proportional thermostat. Proportional thermostat talks about a particular temperature, and depending on the temperature, it gradually opens or gradually closes. So temperature plays the main definitive role here, and this temperature can be time to time measured by this temperature gauge at the inlet and the outlet, and the pressure gauge at the inlet and the outlet. You should be clear about the concept of the air handling unit. This is how the air handling unit works. Air handling unit plays a very important role in case of a chilled water piping system. Air handling unit is generally placed, one air handling unit takes care of maybe whole floor of the building. or one air handling unit may take care of a part of the building. It depends on what type of air handling rooms we are getting. Rooms is a big problem in big shopping complexes and such places because of the space constraint, and we get air handling unit into that. So air handling unit, in case we use the air handling unit supplies chilled air. Chilled air. This is the chilled air. This comes through this blower. Why chilled? Chilled water is coming through this pipe, and the hot air passing through this gets cooled, and this goes to the blower system. This gets cooled to a particular temperature. Because of this temperature here, 44 degree Fahrenheit, it is coming. So cooling happens accordingly. If this is disturbed from 44 degree Fahrenheit, temperature won't be maintained in the room. Now, air handling unit in a particular floor, maybe 2 air handling units, maybe 3 air handling units, maybe 1 air handling unit, depending on the area of the room, depending on how many HE rooms are provided, and all these things. If 1 air handling unit is provided in place of 3 air handling units, the room size of the HE room will be very big. Generally, that is not possible. Generally, you will get 2-3 HE rooms in a floor in a big shopping mall. Like you have here the DLF shopping malls, that is in Vasant Kunj. There are 3 shopping malls, prominent shopping malls and other shopping malls. Every floor is supplied with a number of air handling units there. It's not only 1 air handling unit, because the floors are big enough and it cannot be taken by a single air handling unit. Not only that, there is another reason of putting 2-3 air handling units. That is because if you put 1 air handling unit in the system, then if for some reason the air handling unit does not work, the whole floor fails, air conditioning fails. But if you put 2-3 air handling units, at least some part of the floor will be operational. That means air conditioning will be there in some parts of the floor. So it is generally recommended that one big floor should be provided with 2 to 3 air handling units. But for that requirement, you have to have air handling unit rooms. That is HU rooms it is called. So at the beginning stage of the designing, when the architect designs the beginning stage of the building, he marks the different rooms in the building. And in that case, you are to beforehand tell the architect that how many HUs will come in the floor and how many HUs will be fitted and what HU room will be required, what size HU room will be required in different floors of the building. I think it is clear that HU rooms, how the HU rooms are taken and how it is being taken into consideration. Now, I told you earlier, to show that what I told you earlier, this is the supply duct. This is the supply duct. This symbol means continuation of the duct. The duct is continued here. From here, the air gets supplied. This is the air getting supplied. This air is carried throughout the floor. And this air is going to different rooms. Now, generally, in shopping malls, on offices, and in such comfort applications, all the rooms are maintained at some temperature. So, depending on the temperature requirement, say in a shopping mall, in case of a Sunday, the rush is very high. In case of weekday or office day, the rush is less. So, cooling required is less in weekdays. But in case of Sundays and Saturdays, which are closed day, weekend days, the cooling required is more because the people are more. Try to understand, it is purely requirement based. In case of shopping mall, when the cooling requirement is more, very high cooling is required, that means more number of people are there. More number of people means there is more cooling required because people emit heat. You have seen in the heat load. People emit heat into the room. And more number of people means more heat load is being given. So more cooling is required. In that case, the three-way valve will open its port more and more chilled water will flow. More chilled water will flow to the chilling machine. And more chilled water flow to the cooling machine. The flow rate increases in the chilling machine. As a result of that, the heat transfer increases. That means more cooling will be done in the chilling machine. And it comes back at 44 degree again. So you can control this. What I mean to say. In case of Sundays, I am talking when the people load is more. But in case of working days, when the people load is very less, or sometimes maybe in the working days, even during evening, the people load increases to some extent. During noon time, there is very less people load in the shopping mall. Generally, I am telling general trend. So in that case, in the noon time, you need less chilled water flow. What happens? Thermostat senses the temperature in the room and gives a signal to the three-way valve. Three-way valve closes this port and opens this port. Closes this port, opens this port. When it closes this port, no water goes to the chilling machine, and when it opens this port, this water gets circulated to the chilled water, to the chilling cooling coil, and then gets recirculated again like this. Like this. Here it is getting recirculated. That means we are sending less chilled water through the system. So less tonnage of load is being taken care of. Less chilled water flow means less tonnage of load. You understand the tonnage of load, why less it is? Because Q is equal to mass into specific heat into delta T. Mass by volume is density. That means M is equal to density into volume flow rate. So, when we decrease the volume flow rate, the mass automatically decreases. When the mass decreases, as a result, mass is directly proportional to Q. Q also falls. That means heat transfer falls. Heat transfer falls means the tonnage of the machine falls. But you remember, the temperature does not fall or rise, because I am controlling the chilled water flow. So temperature remains at 44 degrees Fahrenheit, which comes from the chilling machine. That we cannot change, because if we change the temperature here, it ultimately affects the temperature in the room. And you have, as an air conditioning engineer, HVAC engineer, signed a contract with the client that you will maintain a particular temperature, say 19 degrees centigrade in the room throughout the season. And it cannot be 20 degrees centigrade. If you have given a contract, he may go to court for that. So to maintain 90 degrees centigrade, you must have 44 degrees Fahrenheit water coming in. And it will be heated to 54 degrees Fahrenheit and going to the chilling machine. And chilling machine again will provide you delta T. That is a temperature difference of 10 degrees Fahrenheit. It comes again at 44 degrees Fahrenheit here, hits at 54, goes to chilling machine, 54 to 44 it becomes, and 44 degrees it comes, and this cycle continues. That means in the total system, you can see the total system, it should be properly temperature maintained or controlled system. HU plays a very important role in the system. In the HU, whatever part, one is 3M mixing valve, another is this cooling coil. Cooling coil is not manufactured by HU manufacturer. Cooling coil is manufactured by some other manufacturer. So cooling coil has a particular capacity of temperature transmission. That capacity is delta T of 10 degrees Fahrenheit only, 10 degrees centigrade, 10 degrees Fahrenheit only. That delta T should be 10 degrees Fahrenheit, that it should able to take a heat of delta T of 10 degrees Fahrenheit for a particular GPM or gallons per minute of flow. So depending on tonnage and the flow, it will depend on the tonnage and the flow, and accordingly the temperature transfer, that is mainly the heat transfer, takes place. Try to understand the whole thing. The tonnage decreases, that means the chilled water requirement decreases. Chilled water requirement decreases means this proportional thermostat will be giving a direction to the three-way valve. Three-way valve will bypass, this is called bypass line, bypass more water into that, and it will be circulated like that. When the chilled water requirement increases, means more cooling is required, that case proportional thermostat will tell this three-way valve will open this and it will flow like that. Now to maintain the temperature of delta T, this coil plays a very, very crucial role. Not only delta T, two things, tonnage and delta T. Temperature difference and tonnage, there are two things there. Tonnage and delta 3 is to be maintained by this chilling coil, chilled water coil. And then comes the next thing, blower. This is the fan of the system. The fan, you have already designed a blower. I told you the designing of the blower. The blower, this duct goes to the total system. So I told you about how the blower static pressure and CFM is to be designed. CFM means cubic feet per minute. That is the airflow. And another is how the one is CFM of the blower is designed, how much CFM it will take, another is static pressure. Static pressure means what pressure or friction loss it is undergoing through the whole system. Remember, I was talking about the total static pressure loss in a chilled water in a blower, and according to the blower will be designed. If you give a wrong design of the blower, the air won't reach the last room of the cycle. That means you will be running the AHU, but air won't be reaching all the rooms of the building where you are supposed to supply air. So what will happen? There will be no air conditioning there. You will fail in the contract, and there will be penalty for that. Number one. Number two, you have to increase the AHU size. You have to make modification in the design, and that is a huge cost affair. So you should be very, very particular in designing the air handling unit blower. The static pressure should be able to be taken by the blower, and accordingly it is designed. So there are three things in the air handling unit which you have to take care of. One is pre-filter, one is chilled water coil, one is blower. And other than chilled water coil, pre-filter and blower, there is three-way mixing valve which plays a very important role. In this class, I was mainly describing the function of the three-way mixing valve. In this case, we are using three-way mixing valve which is working proportionately in case of AHU. But when we use FCU, fan coil unit, remember fan coil unit? Fan coil unit is used in small classrooms. Fan coil unit is used in small hotel cabins, small places. A particular room is taken care of fan coil unit. These are small AHU sort of things, small. AHU is a big structure mounted on the floor and supplies a huge building. A fan coil unit is a small AHU like structure, is on the ceiling, false ceiling, above the false ceiling, and supplies a particular room like a cabin, or a particular room like a classroom. Intention is that in a hotel, every day, everybody is not present throughout the day. Somebody goes out of the cabin, he will off the FCU and will go out of the cabin. So there will be no power cost. But in case of AHU, if you run the AHU, there will be power cost in the AHU. AHU will be continuously running for all the rooms which are not occupied. And there will be operational cost of electricity bill, high electricity bill, unnecessary, the client will be paying, which is not prepared. Like in case of classroom building in educational institutions. Some classes are happening, some classes are not there. At that case, you need not run the whole system for classrooms. You have an FCU, you close down the FCU and go out of the class. There will be no electric bill for that, and there will be no further chilled water piping, chilled water circulation for that. So, in case of FCUs, instead of the proportional thermostat, an on-off thermostat is provided. On-off thermostat. Try to understand. I said proportional thermostat which proportionately closes or opens gradually the valves. In case of FCU, you don't need a proportional thermostat because it's a small unit. Here, you have an on-off thermostat. On-off thermostat gives a signal to a three-way valve which cuts down this flow and opens this flow when required. Same principle as in AHU. Or opens this flow and cuts down this flow when required. But it is on or off. Isolates totally. It doesn't go gradually. In case of AHU, it closes gradually. It closes gradually, so the water flow trickles down and then closes, depending on the requirement. But in case of FCU, it suddenly gets closed. FCU is of tonnage, कितना टन का होता है? एक FCU is generally maximum tonnage of 2.5 ton. It comes in 1.5 to 2.5 ton in a central air conditioning system. And it is generally used in case of big buildings where small rooms are there, where central air conditioning unit is there, to save the power cost. So in this case, try to remember, we use in FCUs on-off thermostat, in AHUs we use proportional thermostat. In FCUs we use on-off control of the bypass port and the main port. But in case of AHUs, we use proportional control of the bypass port and the output port. This you have to remember. One is proportional thermostat, one is on-off thermostat. On-off means thermostat is on or thermostat is off. There is nothing in between. There is no close proportional control. And I said you again remember, FCUs are small units, so an on-off control does the purpose very nicely in case of HCU. In case of HCU, it's a big one. You cannot suddenly make the whole water flow off because there's a huge volume of water coming into that, and the valve casing may break if you make a sudden flow of water stop. Not only that, the temperature gradually increases or decreases in case of a big area, in case of HCU. HCU takes care of a whole floor area. HCU takes care of a room. So that is the difference. In case of HCU, since it takes care of a big area, the temperature is to be modulated and controlled slowly. In case of FCU, that is not required because that is a small room. So small room means what? You have a generally window AC or split AC in your rooms in your house, like the small rooms in your house, like a bedroom, being provided with FCUs. There are residential buildings that very rich people, they centrally air condition the residential buildings. In this case, bedrooms are provided with FCUs because people are generally not present in the bedroom other than sleeping at night. So that case, when they are not present in the room, he will go out of the HCU and go out. So the power cost will be the same. I think the class is clear to you, and I was explaining about three-way bulb, proportional thermostat, on-off thermostat, and FCUs and their controls. This is one of the most important controls of the central air conditioning system. You have seen in central air conditioning system, whatever the season outside, the room always remains at the same temperature. Example, you go to airport. Do you understand what is the temperature outside? You never understand. Because you are always fed with the same temperature. Where central air conditioning is there, you are fed with the same temperature continuously. Air is fed at the same temperature. Whatever the room condition outside. How it is done? Because outside condition varies. At noon time it is very hot. In the evening the temperature drops. Accordingly, the three-way valve modulates the control. Three-way valve modulates the control, and because of that, depending on the modulation of the three-way valve, your temperature remains constant throughout in the room. Because you have signed a contract with the client to maintain at 19 degrees centigrade temperature throughout the season, whether it is summer, whether it is monsoon, whether it is winter. In case of central air conditioning, this is the temperature you have to show to the client in every season, whatever the outside conditions. And if you fail in that, your contract fails and you have to pay a hefty penalty for that.